Hi there, grade 9. I'm going to discuss Midline Theorem and Trapezoid. But before I begin with my lecture video, I'd like you to click the subscribe button for you to get notified whenever I upload new lecture video. So what we're going to do is to prove Midline Theorem as well as another proof on the property of an isosceles trapezoid. So given here, triangle ABC, D is the midpoint of AB, and E is the midpoint of BC. So we're going to prove that DE is parallel to AC, and DE is one half of AC. Because midline theorem states that the segment that joins the midpoints of two sides of a triangle is parallel to the third side and half as long. So what we're going to do is to complete the proof here. So the first statement, triangle ABC, D is the midpoint of AB, line segment AB, and E is the midpoint of line segment BC. And this is given. Now, line segment or EF equals DE. Okay, so this is equal to DE. And this is about point plotting theorem. Now, EB equals EC, equivalent. Okay, and this is about definition of midpoint. A midpoint, again, divides a line segment into two equal parts. And these are the two equal parts, EB and EC. So this is the midpoint. So this divides BC into two equal parts. That's why EB equals EC. Now, angle X is congruent to angle Y. Okay? So angle X is congruent to angle Y because of vertical angles theorem. And vertical angles theorem states that vertical angles are congruent. So vertical angles are the result of two intersecting lines. For instance here, BC intersects DF. So as a result, we are able to create vertical angles such as XY and another vertical angles E and this one. Now, we can conclude that triangle EFC, this one, is congruent to triangle EDB. And this is under SAS triangle congruence. Postulate. Now, SAS triangle congruence postulate states that when two corresponding sides of two triangles and an included angle are congruent, we can conclude that the two triangles are congruent. Again, under SAS triangle congruence postulates, whenever two pairs of corresponding sides between two triangles and a pair of included angle are congruent, we can conclude that the two triangles are congruent. So we can conclude here that triangle EFC is congruent to triangle EDB. Now, angle V is congruent to angle W. So this is congruent to this one. Since angle W corresponds to V and they belong to the two congruent triangles, then we can say that the two also the two angles are congruent. And this is because corresponding parts of congruent triangles are congruent. Okay, let's continue. Now, we have AB parallel to CF. Now, we were able to prove that angle W and V are congruent in the previous statements. Another thing, the two angles are also congruent because they are actually alternate interior angles. And if the two are alternate interior angles under the alternate interior angles theorem, if two lines form congruent alternate interior angles, which are W and V, with a transversal, so we define a transversal line as a line that intersects parallel lines. For instance, we can say that in the illustration here, BC is a transversal line segment and DF as well is a transversal line segment. Okay. Now, again, under the alternate interior angles theorem, if two lines form congruent alternate interior angles with a transversal, then the two lines are parallel. So I'm referring to AB and CF. So this is about alternate interior angles theorem. Now, AD equals DF. So this one, or rather AD equals DB. Okay. And this is because of definition of midpoint. We know that point D is the midpoint of AB, and this point D divides AB into two equal parts. And the two equal parts are AD and DB. So we can say that the length of the two sides are equal because of the definition of midpoint. Now DB equals FC. Now take note class that DB here corresponds to FC. And in the previous statements, we were able to prove that the two triangles here are congruent. And these corresponding sides belong to the two congruent triangles. So we can say that the length of DB equals FC because corresponding parts of congruent triangles are congruent. Now, we can say that AD equals FC. So by working on the previous two statements here, since each statement here, since the left side equals the right side and they have dB here and dB here, so we can conclude that AD equals FC. And this is under transitive property. Now, quadrilateral ADFC is a parallelogram. Why? So I'm going to expand the reason here. Now, if two pairs of sides of a quadrilateral are parallel and congruent, are parallel and congruent, then the quadrilateral is a parallelogram. That's how we define a parallelogram. we have two pairs of opposite sides parallel and congruent. So we can say that ADFC here, ADFC is a parallelogram. Now, DE is parallel to AC. And this is about definition of parallelogram. Since DE and AC here belongs to parallelogram ADFC, then we can say that the two sides are parallel. And this is because of the definition of a parallelogram. Now, DF equals DE plus EF. Okay, so where is DF again? Here. So DF equals DE plus EF because the two are the equal parts of DF, which is equal to 2DE. Okay, and this is about addition property of equality. Okay, and then AC equals 2DE. Now, we got this 2DE since we know that DE is equal to EF because the two are equal parts of DF. Now, we can replace EF here by DE because DE equals EF. And by combining DE and DE, we'll get 2DE. So, we replace EF by DE because EF equals DE. So, DE plus another DE equals 2DE. So, that's why this is about addition property of equality. Now, AC equals 2DE. Now, in a parallelogram, any two any two opposite sides are congruent. And AC is the opposite sides of DF. So we can say that the two are congruent. Now, DE equals 1 half AC. As we multiply each or both sides here by 1 half, we got DE equals 1 half. DE here equals 1 half AC. And this is about multiplication property of equality. Now, we were able to prove that DE is parallel to AC and DE is 1 half of AC. So we'll proceed now to trapezoid. A trapezoid class is a quadrilateral with exactly one pair of parallel sides. In trapezoid, the parallel sides are called bases. A pair of angles that share a base as a common side are called a pair of base angles. A trapezoid with the two non-parallel sides, take note of this, have the same length and which is called as an isosceles trapezoid. So this is have the same length and we call this as an isosceles trapezoid. The base angles of an isosceles trapezoid are congruent, and this is what we're going to prove. Okay? So this is an example of trapezoid here. If AB equals CD, then we can say that this trapezoid is isosceles based from the definition here. A trapezoid with the two non-parallel sides. So the two non-parallel sides here are AB and CD. If they have the same length, we call this as isosceles trapezoid. Now, we're going to prove the property of an isosceles triangle which states that the base angles of an isosceles trapezoid are congruent. And we have here isosceles trapezoid AMOR with MO parallel to AR. And we're going to prove that angle A is congruent to R, which are the base angles, and AMO congruent to angle O. Okay? So, if we are able to prove this, so we can say really that this is isosceles trapezoid. So, let's complete the proof here. Isosceles trapezoid AMOR with line segment MO parallel to AR. This is given. Now, AM is parallel to OR. Now, statement 2 is supposedly AM is congruent, not parallel. AM is congruent to OR. I mean, line segment AM is congruent to OR. So this is congruent to this. And this is about definition of isosceles trapezoid. If the two non-parallel sides of a trapezoid are equal, then we can say that the trapezoid is isosceles. So that's how we define an isosceles trapezoid. Now, from M, draw ME, which is parallel to OR, this one, where E lies on AR. So that's why we represent this by a broken line. And this is about construction. Now, quadrilateral more is a parallelogram. And this is definition of parallelogram. How do we define a parallelogram? A parallelogram has two pairs of opposite sides equal and parallel. So this is parallelogram MORE. So we were able to prove that AM, rather MO or ME parallel to OR, and then MO parallel to ER here. So this quadrilateral is also a parallelogram. So this is about definition of parallelogram. ME is congruent to ano, it's ME. So this one is congruent to OR. Okay? And this is because in a parallelogram, any two opposite sides are congruent. And ME is the opposite side of OR. Now, number 6, MA is congruent to ME. Okay. MA is congruent to ME. And this is about transitive property. From the previous statements, we have AM congruent to OR, ME congruent to OR. So we can say that AM is congruent to ME, which is the statement number 6. Okay, let's continue. Triangle AME is an isosceles triangle. So this is about definition of isosceles triangle. An isosceles triangle has two sides equal. So this is AME, and the two here are congruent. Now angle A is congruent to angle 1. Okay, so the two here are congruent because the two are base angles of this isosceles triangle. So base angles of isosceles triangle are congruent. Now, angle 1 is congruent to angle R. Since angle 1 and angle R are corresponding angles, so the two are congruent under corresponding angles theorem. Now, angle A and R are congruent from the two previous statements here. Since A is congruent to 1 is congruent to R, so we can say that the two are congruent also from transitive property. Now, angle A and angle AMO are supplementary angles, as well as O and R are supplementary angles. Now, same side of interior angles, same side of the transversal lines are supplementary angles. So A and AMO here, as well as O and R. So they belong to the same side of interior angle theorem. So this is about same side, same side interior angle theorem. So we can say that angle AMO is congruent to angle O. Why? Supplement of congruent angles are also congruent. Since we were able to prove that that this pair of angles are congruent as well as this one. So A and R are congruent as well as this one to this, and the two are base angles. So we can say that really the base angles of an isosceles trapezoid are congruent. So this is congruent to this while this is congruent to this. So that's it for now, grade 9. Thank you for listening.